All right, students, today we are continuing our study of solids, and our focus today is going to be on spheres, surface area and volume of spheres. Let's go through a little bit of our vocabulary first. I've got the definitions listed for you and some pictures. Here it says the set of all points equal distance from a given point. Now that sounds like a circle, but here when it's three-dimensional, here's the given point, and then all of them that are equal distance this way and this way, anyway, that's going to be the definition of a sphere. It's not just two-dimensional now, it's three-dimensional. Okay, the given point from which all points on the sphere are equal distance, well, that's that beginning point. This one right here. Okay, so that's called the center of a sphere. Center of the sphere. Okay, so I'm just going to highlight this for you. I'm talking about this right here. That's the center. Next, I have a segment from the center to a point on the sphere. From the center out to a point, it's the same. We call that the radius. This one is the radius of a sphere. Okay, so here, highlighting that for you, I'm talking about this one right here, radius. A segment whose endpoints are located on the sphere. So here is your segment. You've got one endpoint here and one endpoint here. We call that a chord. Chord of a sphere. And we make the distinction because you could be talking about a chord of a circle versus a chord of a sphere. So this one right here, that's what we're talking about. Now, here it says a chord, so we're talking about a segment that goes from one side of the circle to the other. So a chord that contains the center of the sphere. Well, that goes all the way across through the center. That is a diameter. Okay. So here, talking about the diameter. And then the intersection of a sphere and a plane that contains the center of the sphere. So you can think about a plane like down here that's cutting into the circle, and it goes actually through the center, where it comes, like this one does, comes straight through here. So it creates this circle, and we call that the great circle. Okay, so the great circle, we're talking about these right here. This one. So if you think of the Earth, that would be like the equator. This one right here would be like the equator. But it doesn't matter. There's going to be millions and millions of these, because it can be, the plane can intersect it in many different angles, but it has to go through the center. Okay, the next one. One of the congruent halves of a sphere. So if you take a sphere or a ball and cut it in half, we call that a hemisphere. So a half a circle would be semicircle. This one is a hemisphere. Not semi, it's hemi. So this, we're talking about this one up here and this one down here. Both of those are hemispheres, or half of a sphere. Okay, so now we have two theorems. We have the surface area of a sphere theorem, and we have the volume. So let's focus in on those. The surface area of a sphere is 4 pi r squared. And it's r squared because it's area, where r is the radius of the sphere. Volume of the sphere, the volume of a sphere is 4/3 pi r cubed. Now remember, volume is cubed, so that's why it's r to the third power. Okay, so over here, a lot of people, when they're plugging this into the calculator, have problems looking at it this way. So here's another way of writing it. You could put 4 and then pi and then r cubed on top divided by 3 on bottom. So this is another way that people write it, and this tends to be a way where you make less mistakes. All right, folks, let's go over to page 2. On page 2, we have a couple of examples that we're going to do together, and there's going to be some that you're going to do by yourself. Okay, first of all, in both of my formulas, I needed a radius. If I look here, it says find the surface area, SA, and the volume, V, of each sphere. Use the pi key and round all answers to the nearest tenth. This time it's tenth. In the future it may be hundredths, or it may be round to 4 decimals. You always have to pay attention to what they're asking. They might even ask you for the exact answer. So make sure you always go back and read your instructions before you give an answer. Alright, so now, looking at this one, I am given the radius. The radius is equal to 3.5 inches. Okay, I'm just going to write down that I'm going to remind myself that the surface area is 4 pi r squared. And over here I'm going to write down the volume is, and I'm going to write it down the other way, 4 pi r cubed over 3. Yes, it's 4/3 pi r cubed, but this is the best way to write it down. Okay, so now we have to plug in our values for our radius. That's going to be 4 pi, and that's going to be 3.5 squared. Now, when you use your calculator, 3.5, you can use the square key, which is right here, or you can use the caret key, which is right above the division sign. So squared, enter, it's 12.25, or you could say 3.5, up arrow 2, because that just means to the second power. And it doesn't matter which way you do it. Let me see if you can see that. There you go. They both equal the same thing. Okay, so writing that down, that's going to be 12.25. Then we have to multiply it by 4. So times 4. So that equals 49 pi inches squared. Now this is my exact answer. So now what I want to do is multiply that by pi using the pi key, which is also that caret key, but you have to use the second key, second caret key. So I get, that's going to be approximately 153 point, round to the nearest tenth, so this would be 9, and that's going to be inches squared. Okay, the next one, volume. That's going to be 4 pi 3.5 to the third power, then divide all of that by 3. So This time I'm going to use my caret key. I can also use the math key. It's going to be 3.5. If you choose the math key, then you're going to want to scroll down until you see this little teeny tiny 3. It's the number 3. So scroll down and enter. And so you'll see 3.5 to the third power. When you enter that, that's what you get. Or you can say 3.5 up arrow or caret key 3, and you get the same thing. Okay, so take that, multiply it by 4, and divide by 3. Oops, sorry, my bad. I take that, and I multiply by 4. Then I multiply by pi. Now divide by 3. And I get 179.6, I have to round up, inches cubed. Okay, on this next one over here, I am given from the bottom to the top is 4.2 feet. So my radius, that's like a diameter, so my radius would be half of that, 2.1 feet. Again, I'm going to start with my formula, 4 pi r squared. So that's going to be 4 pi 2.1 squared. 2.1 squared is 4.41 times 4. That's going to be 17.64 pi feet squared. That's considered to be my exact answer. Now multiply it by pi in your calculator, and you get about, remember to change these to squigglies, 55.4 feet squared. Volume, 4 pi r cubed divided by 3. That's going to be 4 pi 2.1 cubed divided by 3. 2.1 up arrow 3 times 4 pi. Now divide by 3. I get 38.8, because I have to round up, and that's going to be feet cubed. Alright students, I want you to do number 3 and number 4 by yourself and bring them in. Okay, here it says find the volume of each sphere described below. Leave your answers in terms of pi. In terms of pi means the exact answer. Okay, so here the diameter is 8 feet. Well, if the diameter is 8 feet, then I know that the radius is going to be 4 feet. And that's all I need, because I know that the volume is equal to 4 pi r cubed divided by 3. So that's going to be 4 pi, and that's going to be 4 cubed divided by 3. Okay, so my exact answer on this one, that's going to be 4 pi times 64 divided by 3. Well, I have to clean that up a little bit, so I'm going to multiply the 64 times 4 to get 256. 256 pi divided by 3. Now, if you plug in the 256 divided by 3 and do the math, enter to reduce that fraction, you're still going to get 256 divided by 3. So you can leave it this way, or you can change it to the mixed number, which is going to be 85 1/3 pi. So it's either this one or this one that will work. But you need to also put your label, and that would be feet cubed. Make sure you put feet cubed. Okay, now on this next one it says a great circle has a circumference of 24 pi. Now remember that circumference is equal to diameter times pi. So diameter times pi, so that just tells you that the diameter is really 24. So the diameter equals 24 inches. Well, that means that the radius is going to be 12 inches. Now plug that in. You get volume equals 4 pi r cubed. Or, that's going to be divide by 3. 4 pi 12 cubed divide by 3. Okay, so 12 cubed is 1728 times 4 is going to be 6912, and then divided by 3, I get 2,304, and don't forget about the pi, and that's going to be inches cubed. And remember, that is your exact answer. Leave it in terms of pi. So all I did was I did my 12 raised to the third power first, then I multiplied by 4, then I divided by 3. I want you to do this one by yourself and bring it in. I want you to change this one, though, to 48. That should be 48 pi feet squared. That's, oh, I'm sorry, no it's not. That's area, my bad. I'll go ahead and do this one for you. So here, I know that area is equal to pi r squared. And then area is 49 pi. So that means that the 49 is equal to the radius squared. So square rooting both sides, I know that my radius is equal to 7. Okay, so volume is equal to 4 pi r cubed divided by 3. So that's 4 pi 7 cubed divided by 3. 7 to the third power is going to be 343. Multiply that by 4, divide by 3, and you're going to get a number that keeps repeating. So, there you can see it. So, I want to hit math, enter, enter, so it doesn't reduce. So I'm going to leave it as 1,372 pi divided by 3, and then make sure you put feet cubed. So there's my answer right there, my exact answer. And yes, of course, if you wanted to write this as a mixed number, it would be 457 1/3 pi feet cubed. So either or. Alright, now these are the ones that you're going to do by yourself. These are your check for understandings. And it's going to bring some knowledge in from the previous lessons. I'll walk you through the steps. Okay, so here, when you do this one, you're going to find the surface area of the whole sphere and then cut it in half. Now make sure that you go back and add in this circle, because a sphere is just going to be this part out here, like a cup, the outside of the cup. But since we want the total surface area here, you've got to add back in the circle. Volume, you find the volume of a sphere, and since this is a half of a sphere, a hemisphere, then you want to cut it in half. Over here, you're going to have to find the surface area of the cylinder minus the top of the cylinder, because this hemisphere is sitting right on top. So while you count this bottom base, you do not count this base up here. Then you're going to find the surface area of this hemisphere. So you're going to have to find the whole sphere and then cut it in half. But remember, it's not like this one. You don't go back in and add, because these two are touching each other. So that area is not exposed. Okay. Here, the volume, you're going to have to find the surface area of half of a sphere, so the hemisphere. and you're going to have to find the lateral surface area of a cone. But you're not going to add in the base of the cone or that circle of the hemisphere, the base of the hemisphere. Over here, you've got two hemispheres, and remember, two equal hemispheres could go together to be one sphere. So when you're finding the surface area of this one, it's find the whole sphere and then find the lateral surface area of the cylinder. When you're finding the volume, it would be the volume of the whole sphere plus the volume of the cylinder. Alright folks, make sure you bring in these 4 problems so that we can go over them and you can get full credit for your notes. And that's it for notes 12.6.